Namaskaram everyone, welcome back to the 80th episode of Master Unreal series. And in the last episode you saw how we set up our health system, and in this episode we are going to work on the gameplay effects where we will apply burn, chills, and we will see how you can create the effects that you have in God of War or in Sekiro, where you consume items to increase your health, max health, and you can consider the debuffs like burn, chill, and all that. So we will do that stuff in this episode. So if you haven't seen the previous one, I highly recommend you check out because I have already explained the theory. In this one, we are going to straight away implement it. So without wasting any time, let's get started. Okay, so let's create the gameplay effect first. So I'll go under the effects and we have heal and damage. So now I will create one more. That is gameplay effect GE burn. Okay, then I'll create one more by duplicating it and I will say chill, and then these two are elemental and I will create a separate one that is poison. Okay, these are the three gameplay effects that we want to apply. Now first thing, we would like to use the executions, not the modifiers, because we are going to have the resistance features as well. So what I'll do, I'll open this and you see it is asking for the calculation class. So you are going to create that calculation class in C++. So tools, new C++, and search for execution and go for gameplay effect execution calculation. So next, and I will rename it to elemental damage execution. Okay. And I'll open my ability system and I'll create another folder, call it executions, and I'll select this folder and create the class. So you have this damage execution. Now let's override the function which gets triggered when the gameplay effect with this calculation is executed. So it's a public one, virtual void execute implementation, and it gives you the gameplay effect context parameters. So f gameplay, okay, and execution params. The second parameter which it gives is the f gameplay effect custom execution output, reference of it out execution. All right, and it is constant and overridable. All right, so this is the method that comes with this class. Let's create its implementation. Okay, now burn damage can be decided by the thing that is causing the burn. It could be a burning sword, could be a burning area, or it could be a normal fire around you. So in different cases, the magnitude will vary. So first of all, you need to get the spec of the gameplay effect so that you can access how much amount of damage is coming. So I'll get the spec from the execution params. It's a structure. So get owning spec. Now you can see it is giving you the F gameplay effect spec, which is a constant. Okay. And I think it was a reference. So now let's get the magnitude of the damage, which is set by the caller, whoever is causing the damage. So I'll get it from spec, which is a struct again. So use dot get set by caller magnitude. If you remember in the gameplay ability effect heal, which we did and created earlier, you used to pass in the modifiers set by caller magnitude, and you used to pass the tag and the value was stored with this tag, right? So we will create a tag in the base gameplay tags.h. I'll create a tag here and let's call it tag damage, not damage, let's say data damage. Okay. And let's copy this tag and define it in the CPP of base gameplay tags. So I'll replace this here and I will call this data.damage, damage magnitude. Okay. Now you can use this. Let's include the base gameplay tags.h and I will use base gameplay tags and tag data damage. Okay, so you will get that, and warn if not found. No, we don't need a warning, and the default value, if it is not found, we will consider 0. Okay, and for the safe side, in case you receive damage in negative, then we want to consider it as 0, no damage. So I will use the math library and I will access the max function. Okay. So consider this value, but in case if it is negative, then consider the 0 value. Okay. So let's call it our base damage. Okay. And if this base damage is greater than 0, then only we will apply the effect. So if it is greater than 0, or let's say if it is less than or equals to 0, then return. And if it is valid, then in the execution output, we will pass this modifier. So out execution output, add output modifier. Right now we are just considering the normal damage. Then after testing this, we will apply the resistance part. So f gameplay modifier evaluated data. And now you need to get the damage attribute. And if I go to my health attribute set, you see you have defined the damage attribute data. So you have to pass the damage, and then this attribute cell will deal with how much subtraction or the health should be reduced and how it should be clamped. So all that will be done by this attribute set. We just need to provide him the damage. So you need to get the health attribute set class here first. So ability system attributes health set.h, and now you can access u health set, get the damage attribute, and then we have to pass the operation type. So it is additive. So f gameplay mode of operation, we will choose additive. And what is the amount? That is your base damage. Great. So you have created the modifier. So see, it is also doing the same thing. It is just giving you the space of making the calculation. Otherwise, if you check our older gameplay effect, we were doing the same thing. We passed it the health attribute. We defined the modified operation. Then we gave it the color by magnitude tag, and the value was set by you in the blueprints. So this is doing the exact same thing. I hope you are not feeling anything new here. Okay, so once this modifier is applied to the damage attribute, which belongs to the health set, you will receive the notification. So Unreal Engine gives you methods that gets called before the effect is applied and after the effect is applied. So they are under protected specifier, virtual bool, pre-gameplay effect execute, and the type is f gameplay effect mod callback data, and it's a reference data override. Okay, so this will tell you whether the gameplay effect is applied or not. So that is the reason it has bool return type, and same applies for the post. After the gameplay effect is applied, this will be called, this one is void actually. All right, and two more methods we will add. Just like pre and post for gameplay effect, you also get notified before the attribute is going to be changed and after the attribute is going to be changed. So virtual void pre attribute change, and this is constant f gameplay attribute, the attribute that is going to be updated, and what is the new value that is coming. Okay, and you are going to override it. Similarly, you have post attribute change. That means after the attribute is updated, what was the attribute? What was its old value before the update happened? And what is the new value after the update happened? And let's include the struct. So struct. Okay, let's create their definitions. 1, 2, 3, 4. So we will deal with the pre-gameplay effect execute first. We want to check if this gameplay effect will be applied or not. So if we will call the parent implementation to ensure that this gameplay effect will be applied. So pass the data as it is. So if the gameplay effect is not applied, then just return false. We are not doing anything. Okay. And if the gameplay effect is allowed, then just return true. Right now, I'm just making this method so that later on I can address the use of it. For now, let's do the basic simple use case implementation. Now, this is the post gameplay effect. So that's where we need to subtract the health and do all the things. So let's implement the parent implementation first. So whatever effect execution has to work out post applying, then let it get done. Okay, so now if this gameplay effect was applied and the change was in the damage attribute, then we want to capture it. So if data dot, okay, it's not showing. So let's include the gameplay effect extension dot h. Okay, and now you will be able to access the members. We will say data dot evaluated data dot attribute. Is this equals to the damage attribute? So get the damage attribute. If it is equal, then we have to subtract the health. So what we will say, set health. We want to get the current health and we would like to subtract the damage. So get damage. Remember, the damage attribute has been set to some value and we would like to get that damage value, and we will subtract it. And now we have to make sure that you stay between 0 to 100 or from 0 to the maximum health. So we will clamp it. I will say f math clamp. So let's create a variable because we will be using it multiple times. So minimum health equals to 0.f, and we would like to clamp it from minimum health to maximum health. So get max health. Okay, and this damage has been applied, so set the damage back to 0, and let's put the semicolon here. Okay, so let's say if it is not the damage attribute, it's a healing attribute. Let's say you are consuming something which has applied the healing effect. So I have to check for that now, if it is not the damage. So else if it is equals to get healing attribute, and in this situation we will do the same thing. Set health, we will get the health and we will add the get healing value, and it will again and again we will clamp between the minimum and the maximum health, and we will set the healing back to 0.f. But let's say if it is directly applied on the healing attribute, then in that situation I will copy this. If it is get health attribute, we have 4 attributes, right? Healing, damage, health, and max health. Healing and damage are created so that you can easily deal with the calculations and resistance and all that. So in this situation, we will get whatever value that is and we will clamp it between the minimum and the maximum health. So remove this. Okay. Now do not set the health back to 0, otherwise there is no point. Then we will check if the attribute that has been affected is the maximum health. Let's say you collected 5 or 6 items as per your game design, and now that will increase your maximum health. So you are going to check for that gameplay effect. So I'll say get max health attribute. Now in this situation, we have nothing to clamp because eventually it is getting increased. So we cannot put the upper bound. So we will let it be empty. And now we have handled all the 4 attributes. Now let's broadcast that the health has been changed or max health has been changed, for which we created the functions. So you have these on health, on max health change, right? So let's call them. So here my max health is getting changed. So I will call it right here on max health dot change broadcast. Now we need the information, instigator and all that. So I will extract it from the spec. So we will get it from data effect spec dot get effect context, and this will give you the context handle. Const f gameplay effect context handle, and it's a reference effect context. Now from here you can get who is the instigator on which you have applied the effect and who is applying the effect, that is the causer. So you can get both the actors. So actor star instigator effect context, it's a struct, so use dot get original instigator. Then we want to get the causer, so causer effect context dot get effect causer. Okay, so now you have things. Let's pass. First is the instigator, then we have causer, then it was the gameplay effect spec, so we have to pass the value data dot effect spec. So now we need the old value, magnitude, and the new value. So first of all, what was the magnitude? Data dot evaluated data dot magnitude. Then we need the old value. Now you have already increased the health. Remember, it's post gameplay effect execute. That means health has been increased. You don't have the old value. So you have to store it before the gameplay effect is applied. That is the reason we created this pre-attribute and post-attribute change, so that you can get the value by which the health was increased or decreased. Okay, so we will use them. So I'll create variable float health before attribute change. Okay, right before the attribute was about to change, we will store it so that we can retrieve it later. And float max health before attribute change. Now you might be wondering, why do we need the older values? In case you want to show animations, or in the HUD you want to show some kind of effect, then you will need the previous point and the new point. So for that purpose I am storing them. So we will say max health. This one is max health. Okay, so max health before the attribute change. Okay, and now what is the new value? So that is your get max health. Alright, so you have broadcasted the max health change. Now should I do the on health change here? No. Why? Because it's not about healing. Damage is also modifying the health. So we have to consider both the use cases. So we will do after this entire flow is completed. So right here. So I will say if the current health after this change is not equals to the health before attribute change. So if it is not equal, that means the health has been changed. So we have to inform, because let's say if the health was not affected at all, then in that case you cannot fire the event, right? That will be useless. So on health changed dot broadcast, you need the instigator, causer, or let's copy this entire, make it on health changed, and this one be health before attribute, and this will be get health. Okay. Okay, and if health drops to 0, then you want to play out the death animation and all that. For this you created this event, so let's also handle that. We will say if the current health is less than equals to 0, but let's say if some enemy is continuously hitting despite of your health is being 0, or maybe let's say you are still standing in the fire after your health is dropped to 0 because you are in a death mode. So in that case, we do not want to trigger this again and again till the character is destroyed. So for that, I will create another variable that will store, okay, that the health was out, event is in process. So right here, I will say bool be out of health. Okay. And I will say if health is less than 0 or equal to 0, sorry, and out of health is not true, that means we have not fired yet even once. So then we will fire out of health dot broadcast, same thing. So we will copy this out of health. All right, no change. You have to get the health. Now there is a situation, you drop to 0, you are in a death animation, and suddenly you got reborn. Then in that situation, some effects will be applied on your healing, and we have to make this out of health back to false because now you are alive. So like in Sekiro, you die and you are reawakened after taking the blood. Okay, so I will reset the out of health equals to get health less than equals to 0.f in case any above event changed it. Okay, so we are just making sure. By the way, it will happen so fast, like the moment this effect is fired, ability system will be uninitialized and this entire thing will be gone. But in case you reinitialize the same thing, then this will be updated. Okay, so now we have to store the health before the attributes are changed by the gameplay effects. So in the pre-gameplay effect execute, I will store the current health. See, if it is not allowed, then it will return false, so no change. But if it is allowed, then true. So right before true, we will update. So health before the attribute change, get the health at this moment. Okay, and max health before attribute change, get health. All right, let's initialize the values when the object is created. So be out of health. Let's make sure it is false intentionally. And copy these two. We will set 0.f. And we also have to make sure that when the attribute change, it is within the range. Okay, so we will create one function that will always clamp the values before attribute is set. So I'll go under protected, clamp attribute. So constant f gameplay attribute float. It's a reference. What is the new value that has been set? And it's not modifying anything. So let's create the logic. So now you might be wondering why I wrote const. When we are clamping the attribute, that means we are editing the value, we are modifying it. So how come it is constant? Constant means the function is not updating anything externally. We are going to update this value because we have a reference. So we are updating the function parameters. We are not updating something outside of this function. Okay. So that's the reason I marked it const. So if it is a health attribute, so if attribute is equals to get health attribute, then in that case new value is equals to f math and the value that we are passing from 0 to max health. Okay, and if it is a max health, then we cannot let it drop below 1. At least your max health should be 1. So if attribute is max health attribute, then the new value will be f math maximum new value or 1.f. Okay, so at least it has to be 1. Okay, so we can call this function before the attribute change happens. So super pre attribute change attribute new value, and once it is done we will clamp the attribute. So attribute and the new value. See, the reason we are doing this clamp here is because not every time the attribute will be updated by the gameplay effects. We are also considering the situation where you can directly update. So that's the reason I'm doing this. So first of all, we will call the parent implementation post attribute change, pass the attribute, old value, new value. Okay. Okay. So now when the attribute is updated, we have to make sure you are within range. Now be very careful and let's revise what you just did. This clamp attribute is making sure that the health is between 0 to max health. That means when the health will be updated, then it will be within 0 to max health. But let's say if it is max health that is getting updated, then we are just considering what is the new max health. So right now, when the max health is made, we have to make sure that the current health is not greater than the max health. Let's say your current health is 10 and your maximum health is 10. Okay. Now let's say your maximum health got cut down to 5 because of some mode, and now your health is greater than the max health. So in that situation, when your maximum health was updated, you also have to make sure that the health is within this new max health. So that is what I am checking here. So that is the reason once the max health is updated, I will perform this check. So I will say if this attribute was max health attribute, then I have to check if the health is greater than this new value that you have got for the max health. So yes, it is greater than this, then we have to clamp it. So now what you are saying, you want to update the health attribute. Okay, so if the health is greater than this max health value, then you would like to update the health. So for this, you have to get the ability system component and apply the modifier. So first let's do that. I have to get the base ability system component. Get base ability system component. Remember, this function is already there in the base attribute set. So every attribute set will have this function, and we have to ensure that it is there. Otherwise it is something that we have to be worried. And now you should include ability system, base ability system component. And now you can call apply mod to attribute, get the health attribute, and the mode of operation is you want to completely replace whatever the existing value is. So you will override e gameplay mod operation is override. And what is the new value? That is the incoming max health. I'll attach a God of War example here in the screen so that you can relate with the use case. And let's say if the health is now greater than 0 and you are dead, then we have to make the flag false. So be out of health if it is true and the health value is greater than 0, then we have to mark this flag as false. That means you are awake. Okay. Also, correction, this should be get max health, not get health. Right. Okay, so right now you have handled the gameplay effects, which means you can change the attributes for a while till the gameplay effect is active. But what if you permanently want to increase the maximum health? For example, like in the God of War or in the Sekiro, you collect gourd seeds, and then after a set of gourd seeds, your max health is increased. In God of War, you fill that meter and it gets increased. So that is not a gameplay effect. Now it's a permanent increase because gameplay effects can be removed, and once they are gone, your health is back to the original base value. So what if we want to modify the base value? Okay, the one we are setting here 100. So to modify that, there is a function virtual void attribute base change, and it gives you the same value. So that's what you call, and we have to make sure that the health is within the range. So we are going to override, and you are going to use this function if you want to increase something permanently. So let's copy this and paste it here. Free attribute base change. Okay, so let's save it. And this pre attribute is a constant. Okay, let's check these errors. First of all, the pre-base attribute change, there is a constant. And then in the post gameplay effect, this is a constant. Okay, that means we have to correct here as well. And there is one more correction. I'm really sorry. This should be old and the new value. You are not getting reference of them. So that is my mistake. I did not read the header file correctly. Let's fix this here. Okay, because technically you are not allowed to change the new or the old value post the attribute is changed, so we will not give you the reference. Okay, so now it should be good. Let's play. Okay, so the project is up now. Let's quickly go in the burn, and I will add the execution. That is your elemental damage execution. Save, and then there is chill. Let's add that. Okay, now I'm leaving the poison for you. Create the execution class, do the same thing, and you will attach that class in the executions. Okay, now let's see how do we apply the burn effect. Okay, so now let's create the areas where you will get burn and chill and poison. So in the blueprints, we have areas folder. Remember this no weapon zone? Let's create one more, that is blueprint class actor b burn area, or let's say burning area. Okay, I'll open this up and I will add a box collider. Inside this, I will add a plane. Okay, and I'll change this color to, let's say, metal gold. All right, you can do whatever you want, but for now, I'll just go and make this small. Great. Now, when you overlap with this box collider, let me increase its extent. All right. So scroll down, go for on component begin overlap. Let me also hide myself here. And as soon as the character overlaps, I will get the ability system component. I will check if it is valid because only the characters will have the ability system component. And now I would like to apply the burn effect. So I have to prepare the outgoing spec so that I can set the damage of this burn gameplay effect. And I will set assign tag set by color magnitude, and the tag was data.damage. Remember in the execution header CPP, you were using the tag data damage, right? So we are using that. So let's cause 10 damage from the burning, and I will apply this gameplay effect that I created. Gameplay effect spec. Okay, that is what we have to apply. So let's apply this spec, compile, save all, and I'll go to my base player and I'll create a sequence pin. Okay, and I will bind to the health component so that I can hear the changes. Bind on health changed, custom event on health changed. Okay, now you can print what is the new value. So let's try. We did not place the area. This is the burning area. Let's scale up, play. You see 90, 80, 70. So the effect is applied. Now what I want is the burning effect should be applied every second for 5 seconds. So as soon as you come in touch, the effect will be applied and it should last for 5 seconds, causing 10 HP per second damage. So go to burn, change the duration policy to has duration, scalable float magnitude for 5 seconds. This will last, and period every 1 second. So let's try now. I will go in touch, come back, 80, 70, 60, 50, 40. Okay. So the damage is applied. Great. Now we have to do the chill as well. So what I can do, I can use the same actor blueprint. I can expose this gameplay effect class, elemental gameplay effect. Okay. Now you can pass whatever you want, and in the magnitude also, let's promote it to variable, elemental damage. Okay, so compile and save. Let's duplicate this, and this is for chill. And I'll go in the plane. I will change this to, okay, so solid blue, and I have to expose that variable. Let's expose them and make them editable, I mean. So here this is chill, this one is burn. The chill will be, let's say, 5 damage, okay, and this will last for 3 seconds. So I will go in the chill and I will change this duration, and this will be for 3 seconds, causing every second. All right, compile, save, and let's try. First I will take the burning, then I will take the chill. You can see 65, 60, 45, 40. So you have the changes of 10 and 5. So you got 20 HP remaining. Okay, so that's how you apply. Okay, so let's do the heal effect and the max health effect. Okay, so I will just delete this one and I'll recreate blueprint class gameplay effect GE heal, and I'll duplicate GE increase max health. Okay, 2 effects. So okay, now let's see the heal. So I told you healing can also be done in the multiple ways. If you have seen in the Sekiro, you have the magical water that you drink and it increase your health in one attempt by, let's say, 50 or 65. And there is another category called pebbles. I don't know if I'm pronouncing that right. If you consume those seeds, it will increase your health every second by certain amount, and it will last for 5 to 8 seconds or something like that. Okay, so that means different items can be consumed at the same time to apply the healing effect. So for those situations, we created the healing attribute. So do not directly use the health, use the healing and the damage if you are manipulating with the health. Okay, that is the one thing. Second, when it comes to increasing the health, there is nothing to counter. When it comes to damage, you have resistance, so you want to decrease the incoming amount. So you were using executions. But I told you, in majority of the cases, if you are not countering the incoming value, then straight away go with the modifiers. Now we know in case of damage, we can have some resistance buff and all that. So we need to do the math. So we use the executions. But in case of health, we want to completely absorb whatever is coming. So I'm sticking to modifiers. That is the second thing. Now let's see how to apply the healing effect. So let's say if I want to drink that water and it will increase my health in one attempt. So use the instant, and in the none go for healing, and you can set the value like 50. This means whatever the current health is, we will add the 50 healing, and you see in the post gameplay effect, you will get the healing attribute. It will get the healing value, that is 50, and it will add to the health, and the healing will become 0 and your health will be updated, right? So this is for drinking or basically consuming something that increase your health in one attempt. Now let's say if you want to go for the pebbles, the seeds. I do not know if I'm pronouncing it correctly, but what happens is if you consume it, it will apply a effect for 10 seconds, and every second in that duration you will get 5 or 10 health repeatedly, right? So for that you will use the hash duration, and let's say it will last for 10 seconds, and every 1 or 2 seconds, let's say 2 seconds, after every 2 seconds it will give you 15 health. Okay, so this is the pebbles use case, or whatever that seed name is. So when you consume it, it will run a gameplay effect which will run every 2 seconds till the 10 seconds are over. So that means 5 times it will run. So it will give you 15 health every 2 seconds. Okay. You can also adjust the amount by using the set by color. So I have told you how to use the set by color. Now let's also try this scalable float. So I will go like instant, and I am increasing my health by 50, let's say. This is the healing water. I will put some image here so that you can connect. Okay, now what about the max health? Again, no resistance, go for modifiers, straight and simple approach, select the max health, and now you can decide what to do. Either you want to add it or you want to completely replace. I would recommend go for add, but if your game design is like overriding, then you can also go for replacing the value. Now in case of increasing the max health, again, let's say if you are considering gourd seeds, you collect 5 gourd seeds to increase your max health by, let's say, 25. Okay, so every time you collect 5 gourd seeds, your max health will be increased by 25. So that is a specific amount that you have decided in your game design. But let's say you want to increase it or you want to go further, then you can use set by color, but go for instant. When I say instant, that means it will increase the value permanently. If you go for hash duration, then it will keep increasing, which we do not want. Okay, so you go for 25. So let's test this much. Right after I have binded to the health event, I will wait for a tick. So, or delay until next tick, and I will increase my max health ability system component and apply gameplay effect to self. Now remember, you are not using the set by color, so you have nothing to update in the spec. So you can directly apply the effect because there is a hard coded value. I'll go for max health, and this will apply the gameplay effect and it will increase the max health. And right after this max health is increased, I want to increase my current health. So let's create a keyboard event H. So what I want to do, I want to get the ability system component. Whenever I press H, I want to increase my health. So apply gameplay effect to self, consider heal. What this will do, it will increase my health by 50 instantly. Okay, so let's test. You see my health is 125 now because 100 plus max health 25 increase got me 125. Now if I touch the chill and the burn, you see my health is reducing. Now I can press H, it will increase my health again. It's 95 now. Okay, so it is working. Alright, so that's it for this episode. I hope you guys enjoyed it. Do let me know in the comments if you have any doubts, confusions, or queries. Feel free to reach out on Discord as well. The link is in the description. And in the next episode, we will do the damage calculation where we will consider like burn resistance, chill resistance. Basically, we will develop the resistance attribute set which can be used by the gameplay effect calculation so that we can finalize the damage. Okay, so the episode was getting longer and that is the reason I'm pushing it to the next episode. So if you like my work and you want to support me, the Patreon and the coffee link is in the description. Please talk to me before you buy any membership. And the code of this entire series is also now available on Patreon. You can check that out. And in the next episode, we will consider the resistance set. Okay, so I'll see you in the next episode. Till then, you take care. Bye bye.